Okay, I'm going to talk quickly about a few different skills that will apply in class to solve equations. First, distributive property. I circled this word within a word distribute because that's all distributive property is. We are distributing the lead factor, here it's -7, to the m and to the -1. So what I do is I take the -7, I multiply it by m, I keep my subtraction symbol. Then I take the -7 and multiply it by 1. So -7 times n is -7m minus -7 times 1 is -7. Remember, subtracting a negative is the same as adding a positive. So this is the same as -7m plus 1. Oh, sorry, m plus 7. I'm going crazy here. So lead factor here is the greatest common factor in this. Alright, so that's the first thing that I wanted to show you, just distributive property. Distribute the lead factor to everything inside. Here's another quick example. Let's say I have 2x squared minus 3x plus 4. Okay? So I would distribute the 2 to everything inside. I would do 2 times x squared minus 2 times 3x is 6x plus 2 times 4 is 8. Alright? So that is just the distributive property. Make sure you distribute the lead factor into all the terms inside the parentheses. Okay, now next. So the next skill I'm going to talk about is just combining like terms. Well, what makes a like term? They have the same variable raised to the same power. So if I look here, that positive 5y and the negative 2y have the same variable, right? And they're raised to the same power, the power of 1. Now, I have these other terms, -9 and +9. Those actually have the same variable raised to the same power. There's no variable raised to no power. So I can combine those terms, which is really cool. So what I do is I just take the -9, add 9 to it, and then I take the positive 5y, subtract 2y from it. -9 plus 9 is 0. Those just cancel out. So what's happening here is I can use the inverse of the distributive property. I can take out that y, which is a common factor, and I have 5 minus 2 inside, right? Because y times 5 is 5y, y times -2 is -2y. And then I subtract in the parentheses and I have 3y, because I still have the y there. So 3y is my simplified expression for that expression. So this can become that by combining like terms. If you have something like this, 3x squared, oh that's a squared, plus 4x plus 2x squared minus 1, the like terms are the same variable, x, raised to the same power. So 3x squared and positive 2x are like terms. Positive 4x is all by itself, -1 is by itself. So when I combine those, 3x squared plus 2x squared is 5x squared plus 4x minus 1. Okay? So don't get confused. We can't combine the x squared and the x because they're not like terms. And the last couple examples I want to give is just combining both skills. Okay? So we have this expression, 4x plus 6 times the quantity x plus 2 plus 3. First thing I'm going to do is use that distributive property to distribute the 6 to both terms inside the parentheses. I'm not doing anything with the 4x yet, so I'm going to keep it. Now I'm going to do 6 times x is 6x. Then I do 6 times positive 2 is a positive 12, and I haven't done anything with the plus 3. Now that I have this, parentheses are gone, I can go back and find my like terms. I have a 4x here, a positive 6x there, and I have these constants, plus 12, plus 3, no variable there. Those are like terms. So I'm going to combine my like terms. 4 plus 6 is 10 x's. 12 plus 3 is 15. So this simplifies to that. Now I can go one step further. I can use that inverse of the distributive property to find the GCF between the greatest common factor between 10 and 15. Now the greatest common factor between 10 and 15 is 5. I can take that 5 out of this expression above. I'm taking it out of this expression. I divide 10 by 5, I get 2 x's. I can't take the x out because it's not common between both terms. Then I take 15 divided by 5 and I get 3. So these two expressions here are equivalent. They equal the same thing. Really cool. Using the distributive property, combining like terms, and then the inverse of the distributive property, I can create these equivalent expressions. Pretty neat what you can do with math. Go both ways, inside out. There's so many different things you can do combining terms. We're going to use this to solve equations in class. Hopefully that gives you a little bit of background on the distributive property, distribute, that lead factor, distributive property, and combining like terms. I hope you enjoyed. You probably didn't enjoy, but hopefully it wasn't too boring, and I'll see you in class to use that. All right.